question, and if he answers it tomorrow,
they will know. Don't warn him.
Okay, Greg.
Leave it in the comments.
If you have to tell us how many times you went down the slope like yesterday in class. I want to know.
Without being asked.
Without being asked. We won't ask you.
All right. 1-3. What is your question? Okay.
3.
5, I believe, was a L'Hopital's.
Okay.
Does that answer your... Okay. On 8. On 8, I have this. Limit as x approaches 0 of radical 2 plus ax minus radical 2 over x equals radical 2. Correct?
Yes.
For the part on the left side of the equal, does L'Hopital's apply?
Yes.
So did you try that?
Yes.
You did. So when you tried it, you got 1/2 2 plus ax to the negative 1/2 times a over 1. Because what is the derivative of ax? If that was a 6x, would the derivative be 6? So the derivative is a. So, is it true that this has to equal radical 2? So what I have is a over 2 radical 2 plus ax equals radical 2.
Okay.
What do you do with the minus radical 2? Is that just going?
What's the derivative of it? Number. 0. Okay, I'm here. What is x? So does a over 2 radical 2 equal radical 2?
I see where we're going here.
That makes some sense. Because the a could be 0.
And that's what happened. You lost that a. So I think a is what? Make sense? Okay, you know where you lost it. Okay, what this review is kind of designed to do is, okay, I'm forgetting on derivatives, I'm forgetting to do this. So now you know you have to do that, right? And you said 9?
Yeah.
I started writing it out. I just
Ditto. Ditto to that.
Okay, on 9, this is what I have.
Oh. Oh wait. Okay. That's yeah. Okay.
All I'm doing is plugging in. Right?
Yes.
Do you agree with that?
Yeah. Then we're done. That's it.
Really? You plug 0 in for h and you got an answer?
Well, I'm fine. You got it because 0's a line.
What I'm going to multiply is by the conjugate of the numerator.
Okay. That's.
And if I do that on top, I do that on bottom, right? So I have the radical 2x plus 2h plus 1 plus radical 2x plus 1, right? Is that the conjugate? Yes?
See, that's me and Harry got the first part, but that part, nah.
Okay. So I have this, correct? It's the opposite sign.
Where did the bottom h go?
Should not be negative.
it's just the opposite side between the two. That's what conjugate is. All right. Agreed. For my numerator, when I multiply conjugates, the shortcut is square the first minus square the second. So I have 2x plus 2h plus 1 minus 2x plus 1 over h times the radical 2x plus 2h plus 1 plus the radical 2x plus 1. If you don't agree, you have to tell me.
Oh, okay. I see what we did. I thought that was the answer when really that's just the conjugates. You know, I was really confused there.
On top, I have 2h. Don't I? Over this. You agree? What happens to the h?
It gets canceled out.
So now on top I have a 2. What is x? I'm sorry, what is h? 0. So I think on bottom I have this. Don't I?
So when you say x
Take
was?
the 2's out, you're good.
Oh, wait, oh, an h, that's what we said, okay.
And so what's my answer?
One, 2,
Okay.
So, me and Hunter, whenever we were thinking about that, we had the right idea. We just didn't know how to get to 8.
Okay.
We're back.
On 1-4, number 1. What it's saying is the first piece, for it to be continuous, when I come to A, for the first piece, it has to equal the same as when I come to the second piece of A. Do you agree with that?
Can you repeat that? I
What
would
does that actually mean?
know what you mean.
Well, do you see there's 2 pieces?
Yes.
And since I want it continuous at A, that means plugging A in the top piece, plugging A in the bottom piece has to give me the same number.
He said, yes, that was my problem.
Do you agree?
Yes.
So, what has to happen is x squared minus a squared over x minus a has to equal 4.
Big shot at that.
You did that.
You agree?
Yes.
You got all real numbers.
Okay, so how am I going to make that happen? Can I factor my numerator?
Oh, no.
Oh, shit.
So those cancel, right? So x plus a has to equal 4. Right?
Then what?
Well, okay. You have to use your answers. Look at question A, 1/2.
Yeah.
If I put 1/2 scratch that. Let's do it this way. It's easier to see. Is x equal to a?
Yes.
So does a plus a equal 4?
2.
2a equals 4. A is 2. I think it makes more sense this way than the way I was
We
doing
did
it.
it normal. Yeah, we did it.
We did it factor, and then we were.
Yeah.
And then we got all real numbers.
Now what?
Okay, that's so weird.
So we didn't know how to do A, so now we didn't know how to do 3 either, so it's being weird.
Okay. You want to go to 3?
Yeah.
Do we
Okay.
factor this one too?
Maybe 5 too.
Now, we want it to be continuous at 1, correct? Which means when I put 1 in the top and 1 in the bottom, I need to get the same number, correct?
Yes.
So what happens when I put 1 in the top?
0. 0. 0 to 0.
I get 0 over 0, correct?
Yes.
What do I use when I get 0 over 0? L'Hopital.
Really? This isn't even open.
Well, it is, because that's what I'm trying to find, is the limit as x approaches 1.
Oh, gosh, this is insane.
So did you do L'Hopital?
No, because it didn't.
So we put it equal to 0. And then we got 0.
Yeah, that didn't work, did it?
0 equals 0.
So I think I have 1/2 times 3x minus 1 to the negative 1/2 times 3 minus 1/2 times 2x to the negative 1/2 times 2 equals A, right? Three over 2 radical 3x minus 1 minus 1 over radical 2x is what I want to know. What's x? 1. So I have 3 over 2 radical 2 minus 1 over radical 2 equals A. Did you solve that? You know how to solve that? Okay.
Oh.
What'd you get? Okay, we're on 1-5, number 6, correct? The easiest way to do this is I want the limit as x approaches infinity, and I'm going to divide every term by e to the x. Okay? So I have 6 over e to the x plus 3 e to the x over e to the x over 3 over e to the x minus 3 e to the x over e to the x. You agree?
That's
How
just
would I
right.
just
Just see that.
Yeah, we've never done that.
Actually, we did that in Algebra 2.
I would too.
Yes,
Back in the old days.
actually we did.
So this test is
Now,
for like.
the bottom line is, the reason I did it is because I said, this 3 to the x, I don't know what to do with it. I don't know how to find an asymptote. So I can get rid of e to the x, and I just have the number 3, I can work with it.
But you have the other easy.
I know, but it's in the denominator. I am approaching infinity, right? So, when I plug infinity in here, isn't this 6 over infinity?
Plug an 8 for us.
Didn't we say a number over infinity was something? 0. So I have 0 plus, what is this?
3.
3 over, what is this?
0 plus 3.
Minus 3. Minus 3.
So is this -1?
Yeah.
That's my first asymptote.
Oh.
We did the first one.
So how is that any different than saying?
Well, it wasn't. The next part is what's different.
Okay.
Okay, now, to look for an asymptote, I have to look as I'm approaching infinity and as I'm approaching negative infinity.
Okay.
Agree?
Yes.
Now, when I go back to this original problem and I put negative infinity over that, e to negative infinity is 0.
What? So it's a 5.
Okay?
What?
E to negative infinity is 0.
Okay. So it's still the same thing? 0 plus 3 over 0 minus 3?
Negative 1 again, so we get 2
Negative 1, so it's 8.
Well, if I...
And then you take out the undefined.
Is this 6 plus 3 e to the x over 3, wait, sorry, I said that wrong. Is this 6 plus 3 to the x over e to the x
Yes.
over 3 minus 3 e to the x over e to the x? Look what happens here.
Yeah. You're left with the problem.
Yeah.
Okay.
You're left with a problem.
What is e to the negative infinity?
0.
So what is this?
Oh my God.
What is this? Which is what?
Question here.
Could I have plugged in at the beginning on that piece? Yes.
Okay.
I didn't see it. My fault. I didn't see it.
You're good. This is just.
I have sine of x over x squared over x squared plus 2x over x squared. Okay?
Do it again. Then you do it again.
Can you just look at the powers and do the power rule?
What are we plugging in? Infinity. If you're hunting a horizontal asymptote, you're plugging in infinity. Right? Now, let me ask you. I'm going to plug infinity in for x in the denominator. All right? I plug in negative infinity, do I get the same answer? Yes, why? Because it's squared. What happens when I square negative infinity? It becomes positive. Same thing as positive infinity, right?
Okay.
All right. So, this, what is a number divided by infinity?
0.
0 over 1 plus 0?
0?
0.
Wait, and this
Why
would
do we
be,
just do the rule?
yeah.
Could you just plug infinity in?
I mean, I just looked at it and did the rule. But
Greater than. Yeah, the bottom's greater than the top.
Well,
but maybe that's a hard.
Sine of x does not have a degree. No, it doesn't. Sine of x does not have a degree.
Does sine of x
No,
first?
no.
That's two problems, except the other one you had to find something. That's really
How are
weird.
we supposed to know that? If there's
Well-
a sine x squared, why isn't there a sine x?
But it doesn't qualify for the degree of a polynomial.
That is weird.
All right.